If you've been dreaming about building with bamboo, you are in the right place. Welcome to Bamboo U. My name is Luis, and today I want to share with you what we will build in our upcoming course here in Bali in April. We are building the Fishbelly toilets. This is not just a bathroom, it's a prototype, it's a test, but also a small piece of architecture used to explore a much bigger idea. So how we design a structure that feels light, elegant, and almost effortless, and still carry real weight as a living roof or a green roof. So what we are building here is not a space or with a specific function. We are building a structural system. The function could change completely. Today is a bathroom, tomorrow it could be a pavilion, a classroom, a house, or even something much larger. At Bamboo U, the main goal is not to teach plumbing or bathroom detailing. The main goal is to understand the structural logic. Because once you understand the system, the scale can be changed, the program can change, and even the material can evolve. But the logic remains the same. This small module becomes a way of learning a larger architectural principle, how geometry can make structure smarter. So we are working with bamboo, 4 meters span, and a roof that asks the structure to stay light while performing with confidence. So the first instinct when we are talking about structure is usually simple. Take a straight beam, then make it bigger, and then make it stronger, and hope that can solve the problem. But the problem is that structure does not work evenly. It doesn't work like that. Forces are not distributed themselves politely. So in a simple span, the highest bending happens towards the center, and that is usually where the beam works the hardest. So maybe the question here is not how to make the entire beam stronger, but how to strengthen exactly that part that needs it most. So this is where the Fishbelly truss comes in. A structure that becomes deeper in the center of the span, where the moment is higher and lighter towards the end. That's why you can see these different areas. The curve is not just beautiful, it's a structural response, a geometry shaped by force. So it almost feels as if the structure remembers where the load wants to bend it, and then in that particular area, it grows there. So this logic has been used for a long time in bridge engineering and steel structures, where efficiency matters and where extra deep is placed where the span needs it most. That's what we can see how this curve in the bridges work. Bridges teaches us something very simple. It forces to increase in the middle, where the structure should respond at the middle where the loads are. So what becomes exciting is taking that same structural intelligence and bringing it into bamboo. Yorkstam has explored this kind of structural thinking in bamboo across multiple projects, showing that these systems are not limited to one size or one typology. So what we're studying here is not a singular object, it's a repeatable system, a system like can be repeated, can be mirrored, can be extended, can be combined and accepted into modular architecture. So the beauty of learning it as this small scale is that this lesson remains useful at a much larger scale. So how does the Fishbelly truss works in structural way? So let's think about the bamboo pole. This bamboo pole works in compression when we bend it. There's compression here and there's also tension here. So the bamboo pole will do this movement. It takes tension, and the distance between them, between this horizontal line, that gives the system more power. So let's say that as I was bending it, there's a horizontal line that wants to go down. So this line and this curve is showing how the beam will behave. So then, the deeper the section becomes, at the middle of the span, the better it can resist the bending. The more pressure that I add here, then because of this movement and because of this element and how the curve is placed, then it will work in a better way. So instead of forcing a straight beam to behave better, we allow the geometry to do part of the work. So bamboo is strong, we know that it's light, we know that it grows super fast and is incredibly efficient. But it's also flexible. So shaping the system will become essential. The truss helps transform that flexibility into a structural clarity. So in bamboo, the structure is never only the member. It's always also the connections, how pieces meet, overlap, clamp, bolt, or even pin, so we can transfer all the forces, and that's where the structure becomes real. So at this stage, the goal is not to finish a full engineering package. The goal here is to understand proportion, to understand force, and understand its structural behavior. So once the logic is clear, the next step is to build the system and let the material teach us the rest. So we have been working on that. We have been testing also the material, and the most important thing is that we're gonna test and we're gonna try everything that we have been doing with our team of carpenters with you guys here in Bali. During the course, we'll test deflection, we'll test joint behavior, we'll test load transfer, stability, and the way the system responds as the weight increases. And if something slips, cracks, deforms too much, or even fail, then it's not wasted time. That is structural knowledge. So what we're gonna do is work with simple elements like this one. This is again a Fishbelly truss in a different scale. So you can see that we have a horizontal element here made out of two different bamboo poles with the curve below. We will have two elements here on one side of the other, so then that can help to create that curve and that bending. Very important to know is that we are not doing any rub, any cuts, any incisions to create this curve. This is called cold bend, and we're gonna do this in many different ways with different species, so we can test how this bamboo beam or this truss will work. So this course is not really about bathrooms and toilets. It's about learning a structural system with the potential to become modular, scalable, and useful across many kinds of architecture. At Bamboo U, we want to teach you systems that open the door, not just details that solve an isolated project. Because structure is not only about resisting loads, it's also about finding the right form for the right forces. You can understand part of it by drawings, equations, diagrams, any other kind of element, but you really need to learn it when you build it, when you put hands on. So we'll be building this system at full scale in our upcoming Bamboo U course in Bali. So stay tuned on our channels because we'll be sharing much more about it. And I hope you can join us in April or in any of our courses later this year. See you in the next build. Wait, before you go, I have something special for you since you stay until the end of the video. I'm gonna give you a discount code of 20% off for this April course that starts next week on the 10th of April. So go ahead and book the course using this code. Hope to see you there.